equations, as you recall, a system of equations is just two equations that are related to each other. So a system of inequalities is just two inequalities that are related to each other, two or more. Okay? So we're going to look at solving a system, and really a system of inequalities. And since we saw that earlier that inequalities really only make sense when we graph them. So unfortunately, we're going to kind of come full circle, and we're going to come back to solving by graphing. And to solve a system of inequalities, we're going to have to graph them. But it's no more than just doing what we've already done with these inequalities. Just we have two of them instead of one. So when I have a system of inequalities, all I'm going to do is graph both, and then look where they overlap. It's exactly the same thing. So for here, I have two inequalities. So in order to solve this system of inequalities, I need to graph both and figure out where they overlap. Let's graph the first one. So our first one here, I'm going to try to use it in multiple colors. I'll do the first one in kind of orange here. So let's see, let's graph this first one. Is this in slope-intercept form? Y equals mx plus b? Okay, so then what's the b? What's the y-intercept? 0. Okay, what's the slope? Okay, what's a better way to write it than just 3? That'll be more helpful. Because now I know that I go up 3 and over 1. And I can just go up 3 over 1, just keep continuing that pattern, and I'll find these points. Is this a dotted or a solid line?
Dotted.
Dotted. There's no bar under the inequality, so this is a dotted line. So I'll connect all these guys. With a dotted line. Okay, I need to shade this. So I need to figure out which side of this to shade. So I need a test point. Can I choose 0, 0?
No.
No, it's right on the line. So we got to pick some different point.
1, 1.
Sure, 1, 1. That's an easy one. So I'll test 1, 1. Is 1 less than 3 times 1? Yeah. So 1, 1 is a solution, so I'll shade everything on the same side. Now if you're not using multiple colors, this is how I would shade. I would take your pencil, and I would draw like these vertical lines coming away from, kind of covering the area you would normally shade. Anyone know why I would shade like this as opposed to just scribbling everywhere? Okay, it looks cool. But we're eventually going to try to figure out where these things overlap. So if your shadings look the same for both, it's going to be hard to tell where they actually overlap. So if I kind of work this way, then you'll notice the next one when I graph my second line and I kind of go straight away from it, we'll kind of get this cool like checker pattern, this kind of crisscrossing thing going on where there's overlapping. So it's just it's a way to help you see where overlapping is if you'd only have one color. Okay? If you have more than one color, then just use the colors and you'll be fine. I'm going to use this kind of light blue here to do the second one. Okay, so is this in slope-intercept form? Yep. So what's my y-intercept? 1. The slope is about negative 2 over 1. So I'm going to go down 2 to the right 1, down 2 to the right 1, up 2 to the left 1. Is this a dotted or a solid line? It's a solid line. Okay, and I need to shade this. It's still an inequality, so I got to shade one side or the other. So let's pick a test point.
0, 0.
All right, 0. This one 0, 0 is not on it, so I can choose 0, 0. So is 0 greater than or equal to negative 2 times 0 plus 1? Is 0 bigger than or equal to 1?
No, that's false.
So then 0, 0 is not a solution, so I'm going to shade the other side of my blue line. So the last piece of this is, now that I've got both graphed and both shaded, the last piece is to decide where are the solutions to this system. Where do these graphs overlap? Okay. And they overlap, and to do that, I'm going to you can take your pencil and kind of draw kind of an outline around. I'm going to take a highlighter and highlight kind of the area that's the graphs overlap. And if you shade it the way I kind of suggested, notice that you can hopefully see where this checkered area is. And down here, there's not overlapping. There's just one. And up here, there's only one, the blue. And over here, there's nothing. The overlapping area the parts where both of these graphs cross or overlapped is in this area. I took a highlighter and I highlighted it. What this means is that any point I choose that's in this area is a solution, or will be true for either one of these two. Well, actually, for both of them. In any of these other three spots, you'll only get at most one. Like in this spot, I only get a solution to the orange equation, or to the first one, but not the second. And in this area, the blue up here, I'll get solutions to my second inequality, but not the first. And over here, there's nothing, so neither of them are true. Where all of them are true at the same time is my solution area. So if I asked you pick a point, if I asked you to choose a point that is a solution to one of those, or ask you which one, like, what is a combination of x and y that is a solution to this system, all you do is go to your graph, pick your favorite point that's in this colored highlighted area where everything overlaps, like this one, which is at 1, 2, 3, up 2. So 3, 2 is a solution. Or maybe you're someone that likes this spot. 1, 2, 3, 4, 5, negative 1, 2, 3. 5, negative 3 is also a solution to this system. Anything in this highlighted area fits both inequalities. Okay. So nothing new. We're doing exactly what we did in the warm-up. We're going to graph, you're going to shade, and then you're just deciding where all those shadings overlap. Okay. If we have 2, it's not so bad. If you have 3, like on the back side, what if I give you 3 things to check? We're going to find where they all overlap. Again, it's going to your graph. You're just using one color of a pencil, just a gray lead-colored pencil. This can be a little bit tricky because you need to be able to tell the difference between all these different types of shading that you're doing. So for this section, it's a really, really good idea to try to get yourself like a colored pencil, marker, highlighter, that sort of thing to help out with the shadings. Okay. Let's do the second one here. Let's try to do the 2 in the back together as well. And with any luck, we'll get time to practice on your own at the homework. Okay. On here, I have not 1, not 2.
Not 3.
There are 3 inequalities. Okay. If I give you 3, chances are I'm probably at least one of them is going to be really easy to graph. In this case, I claim 2 of them are going to be just out of this world easy to graph. The reason is because I have two inequalities here, one that's just a y and one that's just an x. Those should jump out at you as kind of special equations or special inequalities. They have special looking graphs. Do we recall what those special looking graphs are? Jack is claiming that one of them is a horizontal line and the other one is a vertical line. Do you remember which is which? What is a y-only line going to look like? Is that a horizontal or is that a vertical line? I claim it's a horizontal line. Thank you, Kennedy. I claim that a y only is a horizontal line. The reasoning is that this is, if this is an equal sign, this would be y equals 0. This is where y is always 0. And if I go up and down, y is always changing. Y is not the same. Also, I did dotted lines, and I kind of went on autopilot because it shouldn't be. It's a underneath, so these are clearly a solid line. I need to shade this. How should I shade this? What side of this horizontal line am I going to shade? Above or below? Which one? Above. Why above?
Because it's 0.
Oh, because the negative sides don't work.
What does this inequality say?
At 0.
Brooke? That's where all the numbers that are bigger than 0 are. So here is all the y's that are bigger than 0. Okay, one down. Number 2, x's. X only is kind of the partner that goes along with the horizontal line. X only is our vertical lines. So I have a vertical line through -3. And it's not or equal to, so it's certainly a dotted line. Where are all the x's that are bigger than -3? Are they to the right or the left of this line? Greater than goes to the right. Okay. Our last one is the one we got to do a little bit of work for. Because this has got an x and a y, and it's not already in y equals mx plus b. Well, let's rewrite it. Subtract 2x. 3y less than or equal to -2x plus 6. Divided by 3y less than or equal to fraction. What's 6 divided by 3? 2. I'll take my blue line and let's rewrite it so it's easier to graph. So the slope, y-intercept of 2, 1, 2. I have a slope of -2/3, so I go down 2 and to the right 3. I also go up 2 and to the left 3. Is this a dotted or a solid line?
Solid.
It's or equal to, so it's certainly a solid line. Okay, let's pick a point. Let's test a point so we can shade this light blue line here. How about 0, 0? It's not on the line. 0, anything is 0. Is 0 less than or equal to 2?
Yes.
Yeah. So that means this is 0, 0 is a solution, so we'll shade the same side. Oh boy, there's a lot going on now. There's a ton going on here.
Did you take the part in the middle, I'm kind of guessing? Like,
So your solution, and I think you're absolutely right, Angela. Your solution, as we saw on the front side, is where they overlap. So I want my solution in this case, if I have 3, is no different than before. I want to know where all of these inequalities, where their solutions overlap. Where does all of those different colors intersect it? Like, let's find that area. Okay? Kenny, where do they overlap at? Where at? Like up here? I see orange and purple, but I don't see light blue.
Oh.
Right, Brendan.
Like the middle triangle.
This middle triangle thing.
Yeah, right there. There you go. Right.
Okay. Let's test. Let's be sure. So let's look at all these other different possibilities. So like over here is just blue and purple. Here's only blue. Here's just blue and orange, no purple. Here's just orange, orange and purple, all three. The only spot with all three is right here in the middle.
Is it possible that you can have more than just one area in the same equation?
Is it possible to have multiple different areas?
Like shit like that.
For linear inequalities, where we're just graphing lines, you should only have one zone. Okay. When you go to like algebra 2 and you look at some like when you start getting equations that look curve on you, then it's possible to get different zones. But for just the straight lines, we'll only get one possible area. It may be contained like this one. It might be kind of like in the previous one where it just kind of goes off and forever and just like a quadrant. But you'll only have one like area. You won't have like it won't be like in the middle and then like down here to the right. Like you'll have just one spot. Okay. All right. So our solution is in the middle. So I choose any point in this little highlighted area, and that'll be a solution to this system. Okay. Any questions so far on this graphing? Okay. We're graphing system. We're graphing just more than one inequality. Graph and shade. Graph and shade. Graph and shade. Okay. Let's look at the last piece is this nice little story problem. Okay. So in this instance, let's pick variables for the width and the height. How about x and y? How about x for width, y for height? Okay. So let's see what relationships we can get. We know that the logo width, or x, has to be between 3 and 5 inches. So if x is between 3 and 5, I claim we can get our first two from that. If x is between 3 and 5, is it bigger than or smaller than 3?
Smaller.
Better be bigger than 3. X better be bigger than 3. What's another one that we could write? If it's between 3 and 5, then where else does x have to be? It better be less than 5 as well. How about another one? See, it's x, the width, or x is between 3 and 5, so it's bigger than 3 but less than 5. The height, or y, is no less than 2 inches. The height is no less than 2. It's got to be bigger than or equal to 2. And last but not least, the sum of the width and the height is no more than 9. Sum the last piece here says that the sum and the width are the sum of the width and the height are no more than 9. If I add the width and the height, it's no more than 9. If you add the width and the height, it's no more than 9. 1, 2, 3, 4 inequalities that we could write. Okay. Now I'm going to graph this system. Well, that's not that bad because 3 of these 4 are just horizontal or vertical lines. So there's not a ton of thought to go into 3 of these 4. Okay. If x is greater than or equal to 3, we go vertical. X only is vertical, so we go 1, 2, 3 through 3. It's a solid line because it's or equal to. Less than or equal to 5 is at 5. It's also a solid line. And if we can even hopefully make life a little bit easier for ourselves. It said that the width is between these two. So where are all the numbers that are between 3 and 5? Well, they should be between these two lines here. So if I kind of do both of those in blue, I should get the first two look something like this. Y is bigger than or equal to -2 or +2. So if I find horizontal line through 2, y is greater than 2. That's everything that's bigger than 2 or above the line. And last but not least, my non-vertical, non-horizontal line, x plus y is less than or equal to 9. What should I do to be able to graph this last one? We got to write this in y equals mx plus b, slope-intercept form. What's the y-intercept? 9. So 2, 3, 4, 5, 6, 7, 8, 9. What's the slope? Negative x, which is like a -1 in front. Since we want a slope, we'd like a fraction. We'll do -1 over 1. So I'll start at 9 and go down 1 to the right 1, down 1 to the right 1. Solid line. Let's pick a test point. How about 0, 0? Is 0 plus 0 less than 9?
Yeah.
Is 0 plus 0 less than 9? Yeah, it is. So then this is a solution, so everything on this side works. So where's my solution area? Where does everything overlap? What chunk in here does everything overlap? It's got to be in this blue. It's got to be above this orange line.
Oh, it's this little square kind of.
It's called a trapezoid, this little thing.
Actually, I wasn't looking at that part, so.
Okay. So the solution is any point that falls into that area.